So let's do this, guys. So first of all, thank you very much for attending this workshop today. I promise I only have 2 slides, 3, apart from this one, 2 about this one. Very gentle introduction, and then we can get going, okay? So just very brief introduction of who am I. So I'm a senior principal engineer at Blip, working for FanDuel. So for those who don't know, we are around. Blip is a company that is part of the Flutter Entertainment Group. We work with several brands from the Flutter Group. I work specifically for FanDuel. I'm with the operations teams. And yeah, that's basically it. And today we're here to talk a little bit about how can we leverage Kubernetes to make our workloads more reliable. So the idea here is that we want to not just run our workloads in Kubernetes, is what does Kubernetes or associated projects have that can help me, an application developer, make my application more resilient, sustain to failure, etc., etc. Last slide, I promise. So topics. As you guys can see, there's a lot of stuff that I can leverage in the Kubernetes world to make my workloads more resilient. We're going to focus on the things on the left for today, because it's too much stuff, right? It's too much stuff. The idea here is, especially for the ones who are with laptops, is that we do some of the exercises. The way that we're going to structure this is, I'll share with you guys a repo. We're going to just clone the repo, and there's a series of tasks, and we're going to explore each of these topics with a hands-on tutorial, right? So we're going to get an application and getting it running. How do I scale it? What do I mean when I talk about quality of service in Kubernetes? What is SCADA? How do I leverage a readiness probe? What's a pod priority class? Okay, and see those things in action. Eventually, this workshop will evolve to more advanced topics and with a bigger scope, and I'm going to start cover a lot of these things. Everything from the gateway API to network policies. How do I do a canary deployment? What are init containers? How do I manage migrations in a sustainable way in Kubernetes, etc., etc. And as promised, this was my last slide. So for the ones who want to, do the same exercises, just go into this repo, just clone it. So you don't need a GitHub account, but it's good if you have Git installed. Bigger. Yeah, the name is not the best one. Yeah, MCC Ricardo. Come on in. If you guys need power, I advise you to come to these tables because we only have power here. Okay, so once you have that repo cloned, from these requirements, the only things that we'll actually need will be Docker, Kind, and kubectl. That's it. We don't need anything else for this workshop. After the first. So while people are setting up their environment, just a quick show of hands. Who here runs Kubernetes in production? Are you guys application developers, or are you guys more in the operation side? Platform engineering, SRE, application developer? Cool. So here, okay, most people don't. So the idea here is that we will go through a series of challenges. They will be increasing in a little bit of being harder, where we're going to start with a very basic application, and we're going to put it running in Kubernetes, and then over time we're going to do challenges that will make them more resilient without making a few changes to the application itself, but not a lot. For the other topics, there will be more stuff that we will need to do. So to start, the idea here is that we're going to do this from an application developer perspective. So we are going to assume that any tool, it will be given, right? So for example, if I need to scale up and I need Kata, there will be commands for that, but we will assume that some platform engineer or some SRE will be responsible for that part. We are the application developers, we're just using it, right? So we're not going to focus a lot on Kubernetes, autoscaler, Carpenter, and all those kind of stuff. We will assume that if I have Kata available to do autoscaling, someone else is responsible for managing that component. And we're going to do this through a series of challenges. So this is the idea. While people start. So if you can, afterwards, you can do this at home, because I have both the tasks and the solutions, and you guys can redo if you want to. And we're going to start with the first one. So, does anyone know here, not the ones that are running Kubernetes in production, but what's the smallest component that Kubernetes manages? A pod. What's a pod? It's not a container. It's a group of containers that share resources. It can be 1, it can be 1,000 in a pod. So a pod, it comes from whales, if I'm not mistaken, right? A group of whales is a pod. So a pod is a group of containers that are co-located. So if you run a pod with 3 containers, they will all live on the same host. And they share resources. They share storage, they share network. And this is the smallest component that Kubernetes can manage. It will not manage containers. It will manage pods. Of course, the easiest pod to manage is a pod that only has 1 container, so it will basically be a one-to-one. But there's nothing stopping us from having a pod with 1,000 containers inside of it. Probably not a good idea, but Kubernetes has no opinion on that. They nudge you in that direction, but that's okay. So what are we going to do? So inside the app folder, there's a Docker image with a very small application. I'll show you in a bit. And the idea here is that we're just going to build it. We're going to load it into Kind, just so that we don't hold with the hassle of publishing it to a registry, making sure that we have authentication. So Kind has a way to actually just load the container, and then we're just going to create a pod and put it running, right? What's our app? So it is a very basic Go app. It basically is an application, starts a server, has a bunch of routes. Then when we get to readiness probes and liveness probes, we'll see what those routes do, and it basically just starts. And that's basically what we want. Yeah. Sure. Yeah. Same thing, similar. Kind is from the Kubernetes project, and it's what they use to test Kubernetes releases. So they use that. But it's the same thing. If you want to use Minikube, K3S, whatever, it will work the same way. The only thing here is that I'm using the Kind command to load images, so whatever the equivalent is on the other side, it will work the same way. So to speed this up, here we go, deploying an application as a pod. So if you've never built a Docker container, here's just a simple command. I just need to go into that app folder and just do a build, right? I gave it that name. You guys can use whatever name you want, but that's basically it. I'll do here, just so that you guys can see that this works. and that's done. Okay? Just building an image, not doing anything special. So if you guys have kind running, I'm basically just load. Oh, so just something I forgot. If you guys want to start a Kubernetes cluster using kind, again, similar to what Minikube does. Well, if the internet cooperates. There's a configuration file inside that kind folder that will basically start a Kubernetes cluster with one control node and 2 worker nodes, and it will just boot up. It will take a few seconds, and then it's just a Kubernetes cluster that we will be able to access using kubectl. If I do get nodes, here's there. So I have a Kubernetes cluster running locally that has 1 control plane node and 2 local worker nodes. So the worker nodes will be the nodes that will run your workloads. The control plane nodes has all of the API machinery, like control, kube controller, API server, etcd, etc., etc. Kind uses Docker underneath the cover, so it's like Docker in Docker, Inception, but it basically, for our purposes, we don't have to worry about this. We just have to worry that we have an API that we send stuff to it, and it will do stuff. Right? Cool. So there's a command, which is the load Docker image. So you will not be doing this in production, right? So you will not be loading stuff this way into your clusters. But again, for our purposes, we'll just load that image into the cluster so that the cluster can use it. So that's basically what I'm doing here. I'm just loading. Fortunately, I had already done this, so it's just saying, okay, cool, I already have this, but once you guys do it, it will take a few seconds for it to do. So now what do I have? I have a cluster, I have a Docker image, I need to put this running in a cluster, right? So the idea here is, like I told you, a pod is the smallest unit of work that a Kubernetes clusters know how to run. There are different ways to run a pod. A container could be a pod, it will always be a pod, but with different nomenclature. It could be a cron job, it could be a stateful set, it could be a daemon set, but it will always be that kind of thing. Okay. So what is a pod? If I go here into the solutions, and if I look into deploy as application as a pod, README, we should have here. And we'll go through a pod manifest from top to bottom. Come on, internet. Okay. So if you're familiar with how Kubernetes works in terms of manifests, this YAML file will not look strange to you. If you've never seen it, every single file that you'll see from now on will have a structure that will be very similar to this one, but with different values. So the idea here is that every resource will always have an API version. In this case, for a pod, it's v1. It will have a kind. It could be a pod, could be a deployment, all those things, those weird names that I've been saying, it will have one of those. It will have a bunch of metadata. In this case, we're just saying, okay, I want to run this pod, and I want to call it resilient workload app. That's it. And then you have a spec. And a spec, depending on the type of resource, could be something very small, can be something huge. So in this example, what are we saying? I'm saying that I want to run a container. Its name will have the same name as the pod. I could name it whatever I want. I'm specifying the image and the version that I'm running for that pod. I already loaded the image, so it's okay. Image pull policy basically tells Kubernetes what it should do if it doesn't find the image. In this case, I'm just using, if it isn't present on the cluster, pull it down. There's the other most used version is always pull. So I'm basically telling the container, even if you have it locally, always bring the latest version down. Because sometimes we write tags, so we just want the latest tag errors. And then I'm just exporting container on port 3000. That's it. So if I apply this to my cluster, K is actually just, I have an alias to not use kubectl because I'm lazy and I don't want to write kubectl every single time, so I just use K. So K apply -f, solutions, and it will be okay, so basically I just apply this, and Kubernetes said back to me and says, cool, I did this. So how do I get my pods? kubectl get pods. Usually when using, when you use kubectl, it's kubectl, the name of command that you're calling, action, resource, right? kubectl, get me my pods. So if I do this, actually there's a bunch of stuff here that we shouldn't have, but basically it's the first one. I'll delete the other ones afterwards, right? So here's my application. It's running. Okay. I think I need to clean, yeah, exactly. Okay. I only have one. Go here. So now I have one application. If you guys want to test if this is actually working, I can do logs resilient workload app. Okay, basically my application saying I'm here I am. And the easiest way for me to see if it's answering something back, I'm just going to do port forward. Don't worry a lot about what this is. It's there, right? So it's the most basic thing you ever seen, right? But it's there. So Kubernetes knows how to run this. So the goal here is to make our workloads resilient, right? So I told Kubernetes to run a pod. What happens if a node goes down? And that pod is running there for the ones that already have Kubernetes running. What will happen to the application? For example, if the node where the application is running goes down, what will happen to that pod? Sorry? It will be terminated. So shouldn't Kubernetes be able to keep it up? Should, right? But that's not a pod, right? So, but basically what we told Kubernetes is, run me this pod, nothing else. No expectations whatsoever. So if something happens to this pod, I use the example of the node dying, but it could be someone just kubectl delete pod, and it will go away, right? What we want is to make this better, right? So the idea here is that I want to tell Kubernetes, I want you to keep running this pod. If something happens, bring it back again. That's the whole idea, right? So Kubernetes is built on top. So these kinds, most of them are built one on top of the other. So if I want to tell Kubernetes, I want you to run this pod, and if something happens, bring it back, I need to create another construct that will create a pod and will manage that pod. So because at this point, I just told Kubernetes, run me this pod. I didn't tell it, manage it. But if I create a replica set, it will manage it, right? Okay, so if we go into another so here's the example that I was giving. So it's the same YAML file, right? So a very similar one. I'm putting it there. And basically what I'm saying, I apply it, I get the pods, and now I delete the pod. Right, so if I go here, key, get pods, delete. Gone. What I wanted, ideally, because I can do a mistake, is I do this, and Kubernetes spins me another one. Brings it back up. So I can do this with a replica set. And the replica set actually gives me a few things more. So basically, as you can see, the spec is not that different from a pod one. The same. Basically, the API version is slightly different. The kind is replica set. It has a name. I'm basically saying in this example, bring me this pod up, and actually bring three replicas up, and keep those 3 replicas up. If something happens, you need to maintain 3 replicas, right? And exactly the rest is the same. This is the name of the container. This is the image. If it's not present, just pull it down. Expose on port 3000. The only thing different there is the selector. And the selector is what is going to tell the replica set all of the pods that have these labels. You're responsible for it. That's basically what you're saying. So if I launch a replica set, it will launch me those 3 replicas. If I launch a pod on my own with those labels, replica set will say, okay, I got this as well. It will probably bring it now because it only has to have 3, so it will probably kill 1. So let's do that. Now I have no pods. But if I do so Kubernetes just launched me 3 pods. So I could do the same thing, port forward, one of those. Who here has launched a replica set from the ones that have Kubernetes in production recently? Directly, a replica set. Why? What do you guys launch? Deployments. Do you guys know what the difference between a replica set and a deployment? Like, what does the deployment add on top of the replica sets? So we're just saying, okay, here I have a spec. I said it run me 3 pods. It's done. So what's the added benefit of having a deployment? Yeah, that's true. Then one thing is missing. You can go back and forth in versions. So yeah, you can roll it back. So if you have you do a deployment, you have a problem, you can just roll undo. And so basically, a deployment creates replica sets, and a replica set creates pods. So that's the hierarchy, which means that at this point in time, if I want to change this replica set to a previous version, it will be on me to say, okay, actually, it was v0 that I wanted. If I do a deployment, it will actually manage that for me. It will make it easier for me to actually do this work. So let's see how that works. So here's an example. We just get pods. So I'm going to delete it just to. So if you guys want to clean up, just to delete -f file, and it will use Kubernetes will delete that resource. So let's go see the deployment. So as you guys can see, it looks very, very similar again, right? API version, kind, blah, blah, blah. Same thing there. Even the template and the selector are very, very similar. It's just the constructs that will be behind it that will be slightly different. So if I apply this, actually it's deployment, I get the same thing. This guy's crazy, right? So it's giving me the same thing. But here's the deal. Now I can change the deployment, and it will be responsible for actually managing that rollout. The replica set doesn't do that. It basically just creates stuff. So let's see how that works. Let's say that I want to deploy a new version of my app, right? So we're running latest. We can go and let's say that we're going to launch V2. We don't have a V2, right? So this will be a problem. Actually, let me go. I think it's easier if I do it here. I'm going to apply. We're eventually going to get to the rolling updates and recreates part. But here's the deal. So I told Kubernetes, just get me the new version of the deployment running.
you guys know I passed on a wrong version, so it's basically telling I don't know what this is, right? But the three other ones will be running, right? So basically, I already have some resiliency built in here. So it will keep all the replicas that I want running, and if there's some problem, he will say, oh, I can't do this. There's a problem here. I won't progress, right? So we have two options now, which are I can roll it back, but let's see the rollout command first. Basically, I'm asking Kubernetes, what's the status of this rollout of the application, right? And Kubernetes is saying, okay, I'm trying to launch one, and I'm stuck. So there's definitely a problem here. I can see the history of this application. I messed up. So it's basically telling me I have two versions, right? I know about two versions. If I do get replica sets, you guys can see that I have two replica sets, so Kubernetes will manage those replica sets for me. And because there's a problem, I can just do a rollout undo, and there they are. So if I have a problem, I can easily just roll back to the previous version. Kubernetes will handle all of that for me. Okay. The other part that deployments allows me to do very easily is to scale in and scale out. So I have two options here. As you guys saw on the file, I could say, here are the number of replicas. I could edit the file and say, okay, 5, 10, whatever they may be. Or I can use the scale command. So basically what I'm saying here is, Kubernetes, please scale me this deployment and just bring 5 replicas online. And it will bring 5 replicas online. I can do this with whatever I want. And it will get to, and it will get to. And it's managed for me. Of course, this is super fast because the application does nothing, right? But if it's a larger workload, it will have more problems. But I don't have to worry about this. Kubernetes will be responsible for actually putting stuff in place. Questions? Any question up until now? Are we okay? Good? Cool. So I'm going to clean this so that we have a fresh start. No, not a problem. I can do whatever. It should work very, very similar. The only difference will be that I'm using kind to load the image. I'm not publishing it to anywhere. That's the only thing. Other than that, it should be the same. So we're looking at this from a application developer perspective. I'm expecting there's a cluster behind the covers with all the machinery that I need. We're not installing anything. It's just, if I have the API running and the ability to run pods, it will work flawlessly. And we are going to install 2 tools, but it's basically a command, kubectl apply, file somewhere, and it will just install. So, can run. Yeah. No worries. Okay. So we're done with this. So we've seen how to run a pod. We've seen how to run a replica set. We've seen how to run a deployment. We briefly touched on the scaling part. We'll get there and see how can I do this in an automated way, right? So it's cool that I can scale up, but it's much cooler if I'm sleeping at 3 a.m. in the morning and the Kubernetes and I just tell Kubernetes, if this happens, just scale this thing up, right? But before we get there, I'm going to talk about quality of service. I'm going to touch briefly on what I mean by quality of service. So if you go through the documentation of Kubernetes, and then we can follow that link, Kubernetes has this concept of quality of service class. What this means is that when I launch a resource, a pod, a deployment,
I can have 3 classes: guaranteed, burstable, and best effort. Okay. So guaranteed means that I'm going to tell Kubernetes the resources that I need, mostly CPU and memory. And I'm going to say, this is exactly what I need. And Kubernetes will guarantee that those resources are reserved for me, or if it can't reserve them for me, he will tell me, I can't launch this thing because I have no resources for it. And it will tell you. Burstable means that I will give him the minimum resources that I need. But then I can use whatever is spare capacity on the cluster. So I'll say I need 1 CPU, 1 gigabyte of memory. Kubernetes will allocate that for me, but it will not guarantee me more. But if there's available, I can use as much as I want. With guaranteed, it's not like that. If I say I want 1 CPU and maximum of 2 CPUs, it will give me those, and those will be reserved for me, but it will not allow me to go beneath that. And best effort is I don't say anything, and I pray that everything goes okay. Right? So whatever is available on the cluster, it will try to do their best. It has, before going there, what do you guys think is the best option? Guaranteed, burstable, or best effort? It depends, right? But there's a lot of debate on the, if you go on Reddit, on forums, there's a lot of debate between guaranteed and burstable. And both have pros and cons, right? So guaranteed basically guarantees that you will get whatever you need, right? So if I need 1 CPU, a maximum 2 CPU, Kubernetes will actually guarantee that no one will override that extra capacity that you are not using it, because it will guarantee that those CPUs are yours. If you put burstable and you ask for 1, you will have 1. But if you need 2, you're screwed. The reverse of that is that burstable, in most cases, allow you to be more efficient with your cluster usage, because you will say, okay, this is the bare minimum that I need, but if there's spare capacity, just give it to me, right? And we know that we have workloads, we all have workloads that, okay, I need 2 CPUs, 4 CPUs maximum, and the application will be running at 2 CPUs most of the time. And that capacity will just be idle. But again, it depends. It's not a guarantee. So it will be up to you guys to actually understand your applications and see, okay, from these 3 quality of service, what is the one that best suits this application or my cluster? So basically what we are going to do is just create 3 workloads that will explore these 3 capacities. So we'll do this very quickly. If we go into solutions, pod quality of service. So the way that we do this is by specifying a resources section that will be under spec with the memory and CPU that we want. As I was explaining, when I want a guaranteed quality of service, what I'm saying is just give me this amount of memory as a minimum, this CPU as a memory, this is what I need, and this is how much. So Kubernetes will guarantee that I get those resources. In this example, they are equal, but it could be something else, right? So the limit needs to be higher than the request, but other than that, it just works, right? Then I will launch the 3, but it's just for you guys to see. If I'm putting burstable, I'm just saying this is a request, this is the minimum amount that I want, and Kubernetes will reserve that capacity for me, but nothing more. If I get more, I'm lucky. And the other one is similar to the one that we first launched, right? So I don't say anything, and Kubernetes will just work running. One of the good, or one of the benefits of having at least the burstable is that if Kubernetes doesn't have that capacity, it will tell you. You will try to launch, and Kubernetes say, okay, I don't have enough CPUs to put your application running, and it will tell you, I don't have that capacity. On best effort, it's 0. So Kubernetes will basically just say, I'll just start it up, and if suddenly your application starts up and starts consuming 2 gigabytes of memory and it's not available, it will immediately fail. But it will be, for a Kubernetes purpose, it's there. Of course, the application will fail, but then you will enter the famous crash loopback, and it will be there just crashing. If it doesn't have enough capacity, Kubernetes will mark the deployment as failed. So, okay, I cannot schedule this workload because you are asking for capacity that I don't have. And there will be other stuff. So if you have Carpenter or Kubernetes Autoscaler, it will most likely, if it's configured properly, it will, okay, I don't have capacity, but I can, for example, add new nodes, so the Kubernetes will wait for more capacity to come online. We'll not see that part, but if we were going down that route,
we would assume that we have some auto-scaling capabilities at the cluster level, that the cluster has the ability to add more nodes if needed, and then at some point, the reconciler pattern will say, oh, actually, there's a new node here, and I have those CPUs that you requested. I'll do that work for you. So you don't have to worry about this. So let's just quickly launch these 3 applications. Okay. I launched the 3 applications. I give it the name Best Effort Virtual so that we know what they are. I think so Kubernetes will actually assign that, so I anticipate myself. So if I do kubectl get pod -o YAML, it will give me the definition. You probably guys can see that there's a lot more than I passed to the when I launched the pod. That's because Kubernetes, the API server, which is the thing that basically the brain of Kubernetes, it has a bunch of defaults that if you don't pass it, it will basically add them on for you. So if you, for example, if you create a deployment and you specify no replicas, Kubernetes will just put there 1, done, right? So as you guys can see, there's a lot of stuff in there that I never told Kubernetes, and it just figured it out. And one of the things was, as you guys can see at the bottom, but I just scrapped it so it's easier for us to see, is the quality of service, right? So because I specified nothing, Kubernetes just said, okay, so this is best effort, and this is the way that from now on that I'm going to manage this thing, right? If I do the same for the other ones, it will be similar. I don't know how to I'll put the key burstable. It's easy. Burstable and guaranteed, right? So, and this is the way that Kubernetes from now on will do this. And of course, this goes into the topic of vertical scaling. If I need to give more resources to my pod, I just update my limits and requests, and Kubernetes will do that vertical scaling. So, okay, as long as it has capacity, Kubernetes. There's a very big debate about running big applications in Kubernetes. A lot of people are against it, but then we have like stuff like ML models and AI using gigabytes. So Kubernetes has no opinion on this. As long as it has spare capacity, has underlying infrastructure that is able to run your workloads, it has no opinion, right? You say that you need 2 terabytes of memory. If it has it, it's yours, right? Okay. Let's clean this up again. Okay. Questions up until now? Are we okay? Okay. So we talked in the previous section about being able to not having to scale my workloads manually. So ideally, 3 a.m. in the morning, a bunch of people on the other side of the world are very happy with my app, and they just want to use my app as much as possible. Cool. What can I do to actually tell Kubernetes, if this happens, just start scaling this thing out? So Kubernetes has this concept called the horizontal pod autoscaler. I'll bring the example here. So we're going to use 2 ways to scale Kubernetes resources. But the idea here is that I'm going to have a spec that I'm going to tell Kubernetes, and what I'm going to tell Kubernetes is, based on these conditions, if this happens, just start adding pods, right? So this is what I want. So for this, we actually need
for the simplest way is to just deploy metric server. Metric server will basically what it will do is that it will add a new command to the API, which will expose metrics, and Kubernetes will use as, okay, I'm going to look at CPU and memory, and I'm going to do evaluations every time a certain limit is reached based on a definition. I will adding pods up or down. Here we have commands to use just to generate some load on the application, just to see all of this happening, right? So if we go, just to make this, I already have metric server installed, but if you guys go into the task, here you have a command. You guys can see if the metric server is running or not. If not, it's just a kubectl apply. For kind specifically, we need to tell metric server that it will use non-TLS, so that it will freak out saying, "Oh, I don't know what, I shouldn't be doing this." But basically, the idea is going to install metric server. So the way that we see that metric server is actually installed, we can do kubectl top pods. Actually, I don't have any pod running here, but I have pods that Kubernetes has out of the box. And as you guys can see there, it's already telling me, okay, this pod is using X CPUs and X memory. So based on this information, I can create an HPA, which basically tells, okay, if this pod goes, I don't know, above X amount of CPU, just start adding. So how is that done? Let's look at the example. Let's go to the solutions. Probably by now you are already getting tired of all of these YAMLs, but they look very, very similar. They almost look the same. But again, here the API version is slightly different. It's based on the autoscaling subgroup, and it's version 2. I'm creating the new kind, horizontal pod autoscaler, and I'm giving it a name. That's always present in everything I'm saying. The thing that will be different is the spec, right? So now what I'm telling here is, okay, what I want you to do is to scale this deployment that has this name, which is called Resilient Workload Lab. So we're going to deploy that workload again. And the minimum amount of replicas that you will manage is 1. The maximum amount of replicas that you have will be 10. And the type of resource that you can use is CPU. And every time the average utilization of all the pods goes above 50%, launch one more. Yeah, the spec can go, there's a lot of stuff we can do there, but this is the most basic thing that we can do right now. So let's see how that works. So I'm going to deploy the application first. So I have the application here. Okay, it's creating 3 pods. They are running. As you guys can see, I have my application. It's still seeing what the hell's going on. In the example, I put 20% just to make sure that we're not here just waiting for the application to reach an average of 50%, but we're going to generate a little bit of load, and we're basically going to see this application just starting. So let's do that. I apply the API. Ooh. Yes, I could have created the HPA manually as well. Kubernetes has a bunch of built-in built-in command that will create those applications on the other, but we just use the we'll use just the imperative command, right? And we can go there. So we have all of this. So let's generate some load. Actually, I need something else. We should have done this before, but just for the sake of making this easier. So basically what I'm doing here is just calling some endpoint that is doing stuff. It's calculating, I think, prime numbers or something like that. It's just creating load, right?
I started with 3. I'm still okay with 3. The HPA down here is saying, okay, I'm using on average 1%, and if I reach 20, something's off, and I need to do something. 15, right? He's already okay. Something's up, right? At some point, that threshold will go above 20%, and we'll see more pods, hopefully. If not, we can 34%. So at this point, Kubernetes, okay, something's off. I need to get more pods. Just did it for me. I didn't do any scaling, right? I think it's configurable, that you can configure it. If not, the default is a few seconds. I don't know how often, but yeah, but I think it's configurable for the HPA. You can, so we'll see that afterwards, but HPA uses an API. So Metrics Server basically just gets information from pods and exposes it in an API, which is the Metrics API that Kubernetes has. Whatever you can put on an API, you can use on an HPA. So for example, if you have some operator or something that basically exposes the number of messages that you have on a Kafka topic, you can use that. So the type of resource will be different, then it has some convention, and you can use that. Then there are projects like Kata, where you basically can the sky is the limit. You can scale on whatever the hell you want. We're going to see an example doing a cron expression, say, okay, from 9 a.m. to 6 p.m., just scale this out. When you arrive at 6 p.m., just scale it down. But we're going to see that. So, but basically, this is what the HPA does. Right? So it does have a frequency. I don't remember by heart the frequency, but it's a few seconds. I don't know if it's 5 seconds, something like that, but that's configurable. You can tell it to do it faster or slower. There's a bunch of stuff here. I'm going to stop the heavy lifting. So the idea here, and then after a while, it will start bringing those back. And this is also very configurable. So I can say, wait, how long I want to wait for the next iteration to be done. And usually normally I want to scale it down slower than I scale it up, because a lot of times you have a slowness because something happened and less users or there's less reload, but then you have a pickup and you don't want to be scaling down every so often, so you usually scale things down a little bit slower just to guarantee that it was not just a drop and it's things coming back. So at some point, this guy will come back and we'll bring those to 3. I think we started with 3, it was with 6. Last but not least, and just for completeness, what I was talking about, the metrics API. So this is an API, right? So everything, when you talk with a Kubernetes cluster, you're always talking with API. You cannot do anything. If you're an admin, there's stuff that you can do that you don't need to talk with the API, but we're application developers today, so we're not going to mess with the cluster itself. But when you do kubectl get pods, it gets translated into something like this, right? So it's making a call to an API endpoint. So the metrics API doesn't have a command, so I need to just say, so kubectl get raw, it will go to my kube config and say, okay, here's the cluster, just go into this endpoint and get me the metrics for all the pods. As I was saying, you can expose whatever you want in this API. You can enhance it, so you can have something like whatever, Ricardo's /topic, blah, 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 and then you can go into your HPA and say, okay, if this value goes above 1,000, I know that I need more pods to consume my message on Kafka. That's also a very common pattern. So, but basically here there's basically a bunch of resources. So here the example, the last one that it showed is for the local path provisioner, and it's basically saying it's running on the local path storage namespace. Here's the containers, and it's using this CPU in this memory. And you can basically use that spec. Cool. I did something here in the middle that just made my life a little bit easier, that we didn't talk before, but we're going to see it very briefly because you guys probably are guessing. So in the beginning, we launched the application, and we had a pod, right? I connected to a pod, right? I did the port forward. I told you guys you don't need to worry a lot about this because those are different things on how I probably shouldn't be using port forward in production, obviously. But I was connecting to a pod.
now I have 10. How do I do this, right? So if I connect to a pod, how do I get to the other ones? So Kubernetes has this concept of a service, right? We're going to see how to expose, how to do that. I did that before. But the idea here is that, okay, I have a bunch of pods, and I want to tell Kubernetes, if I receive a request for this service, please forward it to the pod, one available pod, something that's available, right? And this is the concept of a service. So service is, again, another YAML file that we'll create that will have an API version, it will have a kind, and basically what we are going to say is, attach this service, and service is not a physical thing, it's a conceptual construct that based in Kubernetes is IP tables underneath the covers. It will do a bunch of routing, and it will basically create all those routes and will monitor which replicas are available or not. And when you do a request for a resilient workload app, it will find one of pod that is available and will send the request there. It supports only round robin, so it's not a physical thing. If you start going down more service mesh and etc., you will have a plethora of options that you can use, list connections, list occupied. But the idea here is that we're going to just use the most basic one. So we're going to do service. I had already deployed it, but I'm going to show you guys what that looks like. So here's the example that I was talking about. So if I have one pod and I do a port forward, I'm connecting to one pod directly, which means that if I send requests, they are all going to that pod. If I kill that pod, it's gone, right? So, and of course, Kubernetes will bring another one back up, but it will have a different name. So I won't be able to connect to that pod. The way that I fix this is by launching a service. And here what I'm telling, again, API version, kind, blah, blah, blah. The selector will be similar to the other slides that we've seen. It will, basically what I'm telling the service is, any pod that has these labels, you are responsible for forwarding the traffic there. And I'm setting up the protocol, and I'm putting the port on the service and the port on the pod. In this example, it's the same, but you could imagine that you could have the service exposing on one port, and I want the traffic to come through another. That's basically it. So if I applied it, I would get this, right? So I get this resilient workload app, and if I do a port forward to that service, it's there. The difference here, I could have done this, if I do multiple curls, it's probably different pods that are answering back. And if I kill one pod, Kubernetes will say, okay, it's fine, I'll just forward it. So this is the most basic way that I have to expose a complete deployment up into the world. And then, of course, if I want to bring traffic from the outside, there are other constructs that I can use. But for inter-process, inter-pod communication, this is probably the way that most applications are set up. Doubts, questions? Okay, cool. Let's move forward to the other ones. Let's start seeing a few more interesting concepts. You guys want to auto-scale with something different, or do you guys want to kill the application when it's dead? I'll leave it up to you. We'll do both. So, you guys want to see Kata? The example here is not very exciting, but we'll go there since we've just done auto-scaling before. So, as we've seen, the HPA only works with stuff that are exposed on the metrics API, and what I can put there is limited. I can be creative. I can expose stuff as metrics, but that are not really metrics, but I can disguise them with metrics. But ideally, for example, how would I create a cron expression in a metric? How would I convert it? It's not that easy, right? So I can create events as a metric, but it gets weird and it gets confusing. There's a lot of abstraction. So Kata is a project that is under the CNCF that allows me to scale my deployments the way that I want. So it has a bunch of built-in integrations already, but you can build your own if you want to. Right? So the idea here is that we are going to create a deployment. For Kata specifically, this is slightly different, but this is a good example of how can we extend the Kubernetes API. And underneath the covers, the Kata will manage those HPAs for me based on the example. So the example here is that I'm going to launch my application, and what I'm saying here is I want you to scale the service every day at 8 a.m. and scale it down at 6 p.m. So this is a common pattern when you, for example, know that you have a specific load on a certain time of day. So for example, let's say that you have a development environment and you want, when your developers are working in the working hours, to have more resources available, and then at 6 p.m. or 7 p.m. when everyone goes home, just scale the cluster down so I have less resource available. So let's see how this works. Okay. So let's create our deployment. I think it will work the same, but just for the sake of making sure that everything working. Okay, basically I'm just launching my application. It has one pod, right? Interesting error. So, as I told you before, Kata will create HPAs, and it will manage those HPAs for me. The error that I just got was saying, okay, you're telling me to create an object to manage this deployment, and I cannot do that because there's already something managing it. So I will not allow. So this is one of the good things of things going through the API server, because the API server will have that reference in its etcd, and it'll say, no, you're trying to scale the same object in two different ways, and I will not allow you, right? So good thing that it has it. So get HPA, if I go here, there it is, and I'm just going to delete that. Okay, so now if I apply it, it will work. Okay, so now I have, let's just see, just 1 second. So if I have pods here, so I have my HPA, and HPA will say, okay, cool, here's my thing, I will scale this whenever you want, right? This is just a very simple example. And it just figured it out that it's past 8 a.m., so it just gave me 3. Yeah. So that's why when companies start going the Kata route, at some point they just go and clean up their HPAs, because they can do the same thing with Kata, but can do more. And it doesn't make a lot of sense that you have, okay, I'm using HPA here, but then I'm using Kata if I can use one tool. But yeah, so the example here is using a cron. There's a bunch of stuff more, and one of the things is CPU and memory, as we have with HPA. But again, this is not something that is native to Kubernetes. This is a project that we need to install resources in. But a lot of the things that I showed you on the first slide that was on the right side, a lot of those things will require other projects. For example, if I want to implement a circuit breaker, Kubernetes doesn't give me that functionality outside of the box. Yeah. No, that's not. There's a section there, if you see, that lists on the right when I start talking about operators, and that's the idea that we're going to start to explore CRDs and all that kind of stuff. And basically CRDs is customer resource definition. And what I'm doing there is that I'm extending the Kubernetes API. So the Kubernetes API allows you to extend it, so I can create a resource Ricardo. And Kubernetes will say, okay, I know what Ricardo is, you give me a spec. Of course, then you need an operator that when I create a Ricardo, that operator knows what to do. And what to do can be do stuff in a cluster, or can be something outside. So one of the most interesting projects that I've seen using operators was
2022, a logistic company in Scandinavia, I don't remember the name, this was in KubeCon, it was in Valencia, and they managed their whole fleet of physical infrastructure with Kubernetes clusters. So they could get kubectl get boat, and it will get them all of their boats. That kind of stuff. That was mad. Of course, they were using projects like what was it they were using? There was some projects too that would make it easier to create those operators, but they managed their physical infrastructure. They could flip switches on and off. They could tune like sensors and increase the heat on something that they needed, or they could monitor how a freezer was working. So they did everything with containers. It is an option. And it worked. They're probably one of the biggest logistic companies in Scandinavia, and it worked for them. But again, this is just showing an example that as an application developer, you can explore. It's not just about running pods. You can explore all of these options with Kubernetes. And for example, a deployment will always do the same thing, right? So it will have a few options for you to roll things in and roll out. But if you have something very specific to your workload, you probably want to create an operator. So one very common use of operators is stateful applications. So for example, if you want to run a database in Kubernetes, you will most likely install an operator, because an operator will know exactly how that application works and will do stuff. So for example, you install a three-node Postgres cluster with a master and a sync replica and an async replica. The operator will know, most likely, that if the main replica goes down, I don't want Kubernetes to bring it back up, right? I basically want to promote my sync replica to master, and it will do all of that wiring and will leave Kubernetes. The only thing that Kubernetes will be doing there is serving as the API entry point, because you can, with CRDs and with webhooks, you can attach yourself to the API and say, if there's anything that someone does with a Postgres cluster, just send it to me. I'll handle it. And basically, API server will just be your API gateway front and say, okay, I know that when I receive the request for Ricardo, I need to send it to that guy and that guy. So if you've been managing Kubernetes workloads underneath the covers, you know that the API gateway is your entry point for the cluster. State is managed under its CD, but then what manages the cluster is the controllers. So Kubernetes has a bunch of controllers, has a deployment controller, has a replica, and those are the guys that look at the state, and they will reconcile it. And that's why you delete a pod. There's a controller that says, oh, actually, you should have 3. I only have 2. I need to launch another one. It doesn't even have to be on the same node, right? So those controllers will keep a reconciling loop that goes on ad eternum, going on, and it will make sure that what should happen. When you create an operator, you're adding your controllers to that thing. And the Kubernetes will start sending you. You cannot attach yourself to the API. Oh, crap. And it's gone. It will come back up. I have no idea. Qualquer coisa aqui, mas pronto, não interessa. É possível, não sei. Ok, mas sim, só para resumir então, sim, isto é um objeto novo, ou seja, isto não é nativo de Kubernetes, ou seja, quando eu fiz aquele kubectl apply, vocês não viram, mas tipo, tínhamos que fazer um apply cada, ele vai criar uma série de customer resource definitions. I don't know why I switched to Portuguese, sorry. It will create a bunch of custom resource definitions that will allow me to do kubectl get scaled object. Kubernetes, up until that point, never knew what a scaled object is. Now it does. And when I create a scaled object, there's a controller running on the cluster. When I send it to Kubernetes API, that will inspect that API and say, okay, every time there's something that's happening, and you can say to Kubernetes what verbs you want to send. So it could be add, update, or whatever. In this case, it basically wants everything. Anything that you will do with a scaled object, just send it to me, and I'll take care of that. Cool. Let's move on to talking a little bit about basic deployment strategies. So Kubernetes has two. When I tell it to roll out a deployment, Kubernetes only knows how to do this in two ways. First one, recreate. Second one, rolling update. If you don't do anything whatsoever, Kubernetes will do a rolling update. If you want to recreate, you need to tell it what it is. So here's the spec. Exactly the same as we did before. The only difference here is that I'm telling Kubernetes to recreate. So what will happen when I tell Kubernetes to use the recreate strategy? Every time I do a change, Kubernetes will kill everything that it's running and will spin up everything again. If I specify the rolling update, or if I don't specify anything and Kubernetes will assume that it's rolling update, it will launch new replicas and delete the other ones. You can control how many of them could be up and down. The only thing that you need to take into account when you're using rolling update is that you will have multiple versions of your application running at the same time, so you need to account for that. So let's see this happening. I'm just going to clean up. Okay. So basically, I have two workloads here. One is deployed with a recreate option. The other one is recreated with a rolling update. So what happens here is, like I was telling before, if I do an update for the recreate, it will basically kill everything and bring it back up. If I do with the rolling update, it will start rolling out new versions. If I'm not mistaken, we put it here exactly. The rolling update has an option, which is a strategy, and I can basically say, okay, you can at most add 50% capacity, and the maximum unavailable pods that you can have is 25%, whatever. And this can be specified both in percentage and in number of pods. So what happens if I set something with a non-existent image, for example? I'm using the recreate. I'm already down, right? Because it basically killed all of the others. It's bringing up a new version that doesn't exist, so I'm down. I'm gone. If I do the same for the rolling update, you guys will see that it's creating new ones. The new ones are already wearing out, but I'm not down, right? I'm not down because I still have the other ones, right? And the service is smart enough to say, okay, I know that these bad boys are not okay, so I'll just route traffic to the ones that are okay. But this is the trade-off. I'm not saying that one is better than the other. Again, it depends. Most of the times what you will want is rolling updates because you want to be resilient, but there will be perfectly valid use cases where you just want to recreate because you don't have to deal with multiple versions running at the same time. You need a clean slate every time that you start your applications. It will depend on your use case. The bad thing of the rolling up or the recreate is that you will have downtime. There's no option, right? So Kubernetes just kills everything and brings stuff back up. And if there's a problem like the one that we're seeing here, you will be down. You can, of course, do a rollout undo, right, and go back to the previous version. Okay, so we've touched a little briefly on how applications are rolled out. Kubernetes has this concept, or these three concepts of liveness, readiness, and startup probes. So it's stuff that you can tell Kubernetes to monitor, and based on the output of that monitoring, Kubernetes will tell you, we'll do stuff. Okay? So let's start with the liveness probe. So liveness probe, in this example, I'm using /live, but it's whatever you want. It works with both HTTP, gRPC, and also running commands on your container. So if you tell it, run this command on a container, or run this script on the container, depending on the expected output, Kubernetes will do stuff. So liveness probe, as the name tells you if the application is live or not. Readiness probe tells you if the application is ready or not. Startup probe is a little bit different, but we will get there. Do you know what the difference and what Kubernetes will do with the liveness and readiness probe? How different will it manage the pods or deployments based on that? Most or a lot of people just put the same endpoint for both, but they have different purposes. Do you know what Kubernetes will do differently when this? Yeah, so what does Kubernetes does if the liveness probe fails? And the readiness? Yeah. So it will use the service, and if you go into the service, it will tell you which the endpoint slices. It will tell you which endpoints are available. If the readiness probe goes down, it will basically remove that from the endpoint. And if the application comes back up, it will add it again. So readiness will just tell you, like our colleague was saying, if the application is ready to receive traffic. And if it's not, it will not send traffic, nothing else. If the liveness probe fails, Kubernetes will kill it, because Kubernetes will assume this application is dead. It's the application that is telling me that it's dead, and that can be just an error or just a timeout, because you can give it a time. It's okay, if you send a request there and you don't have a response in 15 seconds, just kill this thing. Right? Startup probe is slightly different. It was originally, so how did we deal? Before going there, how did we usually dealt with, before the startup probe was created, with applications that took a long time to boot up, because either they're something legacy or because there's something that they need to do? We basically had readiness probes with a huge amount of time. The problem is that liveness and readiness probes always run, right? They are always running because they will manage the whole life cycle. Startup probes only work on startup, and it's not uncommon for to have an application that needs to do a lot of stuff when it starts, and maybe it takes 2 minutes to boot up. So I can set up a probe saying, okay, during these 2 minutes, only when this thing says okay, then you will start booting up the liveness and the readiness probe. So it will allow your application to have the startup time. Yeah. Mm-hmm. Mm-hmm. Yeah. Yep. 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 Yeah, we have a very, very similar use case. So most of our services are written, are JVM based, most of them are Java, and some are quite big because they need to be fast. So we have a lot of in-memory data structures. So we have a few services that need a lot of memory to be able to answer fast. But that means that every time one of those replicas comes up, it needs to do a lot of work. So it needs to ingest a bunch of information, construct that data structure, put everything live. So we use that startup probe, say, okay, maybe the service takes like 2 minutes or 3 minutes. So just wait for it to do its thing, and then you can start monitor if the service is ready or not. But we are giving it some breathing room, because if not, the readiness probe, so you want to use for different use cases. Before the readiness probe was available, we basically used the readiness probe for that purpose, but that would mean that I have a slightly different use case, so I'll be using readiness probe for 2 purposes, but in reality it was just one. And readiness probe runs for the full length of the pod lifecycle, and I wanted the startup probe to say, okay, I just want to make sure to give some breathing room for the application to actually do whatever it needs to do, and then I can start managing the whole lifecycle. So that's a good example, and we have the same problem as well. I think now I know what I need to do. For some reason, it seems to do the trick. Nope. Okay. Okay, so let's see this in action. So again, very, very similar. It's gone again. So again, deployment is very, very similar. The only thing that I'm specifying there is the liveness, readiness, and startup probe. In this example, I'm using HTTP endpoints, so the applications that we built have all of these 3 endpoints. Startup probe, liveness probe, and readiness probe don't inspect the response. They only look at status code. If it's a command that you run, it will be the exit code. If it's an HTTP request or a gRPC, it will just look. So it doesn't care if you send a whole JSON back or whatever. It doesn't look at that, but it will basically assume that if I run live, if I get a 200, everything's okay. If it's not, I have a problem. So let's apply this. Okay, I messed up. No. So as you guys can see there, the application is running, but if you see ready, it's not ready, right? Why is that? If we look at our specification, we are setting initial delay and periods. What these things do is initial delay seconds say, okay, once the pod is live, wait 5 seconds before you start testing stuff, and then test every 5 seconds. And that's the periodicity that it will test. This is configured. You can put whatever you want in there. So basically, I put the application running, and Kubernetes will wait for a little bit of time, and then it will say, okay, I'll start that thing up. So by this time, it should be already running. So now it's running. If we go into our app, we have here a few endpoints that basically just give out errors, just for the sake of the example. So I can set ready fail, live fail, and those were the 2 ones that I have put in there. So what we can do, just to see what happens, I can just change this to other ones. So for the sake of the example, let's go into this thing. Where do I have this? Okay. If I go here and I put the live fail and apply, Kubernetes is rolling out these things, but Liveness Pro is always giving an error, right? So what will happen? I still have one. Also. If I do the same for, I think it's ready fail. You see the restarts? So Kubernetes has already figured it out that something is wrong with this, so it will keep restarting that pod, saying, okay, you're telling me to monitor this endpoint, it's failing, I'll restart it. Things will be different. If I do the ready fail, I'll put this here. So it's rolling out again. It's rolling them out. I think it's endpoint slicer. So basically endpoint slices is what services use underneath the covers to say what replicas will be available. Over time, those things will disappear because it will say, okay, nothing is ready, so I can send traffic anywhere. If only one is failing from the Liveness Pro, Kubernetes will just keep that updated and will keep that list will keep growing and shrinking, and it will be that it will be used to decide, okay, these are ready, I'll send the traffic there, and if it's not going there. But that's basically the gist of it. Cool. We still have a lot of time. I only have 2 more challenges, and the 2 things that we're going to see next are pod disruption budgets and pod priority classes. Let's go with pod disruption budgets first. I'm going to clear things first. Okay, we're good. Less commonly used, but still used in our organizations. The idea of pod disruption budgets is for me to tell Kubernetes, if you need to do some maintenance or something happens, this is the maximum amount of stuff that I can sustain down, or the maximum amount of stuff that you can put down. So the idea here is what I'm going to say, okay, let's say that I have a 10 replica application. And what I'm telling Kubernetes is, okay, if you need to do something, at the very least, you need to keep 5 up, or whatever is my configured value. And Kubernetes will manage that for me. It could be on a percentage base, it can be at a number base, but what you're telling Kubernetes is, this is the amount of guarantee that I need for this application. And there's a resource called pod disruption budget, and that's basically what I'm telling Kubernetes. If you need to do something, if something happens, the example that we're going to see here is just draining a node, so just saying, okay, I want to drain a node. When Kubernetes starts draining that node, it will make sure, if I'm saying, okay, I have 10 replicas, and you tell me that I need 9 up. If there are 3 running here, it will not drain that node, and it will wait for that node to spin up replicas on another node, and then it will drain. And we're going to see that example working. So if we go into solutions, pods, disruption, budgets, we're going to, again, create our workload. We are going to drain a node. So the idea here, let's do this, is actually more fun if we do this. Actually, I was just fixing a bug there. I don't know if you guys noticed, but if you look into the file, I had 10 replicas configured. I launched it, it only had 3. Why? Because I created a pod with another name, with the same name, with the same labels. Kata say, okay, I know what this is, and you only want 3. So it immediately said, no, you don't want 10, you want 3, because you're telling me on a scaled object that you want 3. So I'm going to only manage 3, even though I specified on the pod, on the deployment that's at this point, scaled in this example, it was not my intention, it's completely unintentional, but at this point what happened was, because the scale object managed that resource, Kubernetes just gets hands off and says, okay, you are telling me that everything that goes through a scaled object, it will be managed by you, so the scale object manages this deployment, it's your responsibility to actually do this. But the example here is that I'm basically creating a bunch of pods. It created 10. If I do get nodes, some will be running on worker node 1, some will be running on worker node 2. If I do kubectl drain node local cluster worker, it just did it, right? Done. Just do. So it didn't ask me, oh, actually, I forgot one command. It just does it, right? So there's nothing that's stopping it from doing that job. Once I create a pod disruption budget, Kubernetes will be more careful with that and say, okay, I will do it, but I will wait for the rest of the machinery to ensure that the number of applications that we have there will be actually working. Let's see what we are configuring. If I open the PDB, so essentially I'm creating a pod disruption budget. Again, the selector, I'm just saying, okay, manage the selector, and the minimum amount of replicas that you can have, minimum available, and this, I could put unavailable or available. I'm saying, okay, I need at least 9 up. So if I have like 3 running on a node, and I start to drain it, Kubernetes will wait for 2 of them to be migrated and putting it there. Let's see that working. So if I do here, encore, then local worker. Work. Okay. So now they are both available. Okay, they're probably all running on the other node. So I'll do okay. So I'm basically just recycling all the pods as a command to recycle, just to have them spread out. I'm going to apply the PDB. Yeah, PDB pod disruption. Okay. So if I do a PDB pod disruption, PDB, I'll have there. So basically I'm saying, okay, the minimum available that you can have is 9. If I do my drain command, as you can see there, Kubernetes is saying I cannot evict this pod because you are telling me that I cannot have more than one down. So it will just stay there until everything is scheduled on the other node. And you guys can see every once in a while you have an evicted there, saying, okay, another one spun up in the other room, so I can delete one. And it will keep doing this. So this is a way that you can ensure that if there's maintenance with a cluster, or if there's an upgrade, or if there's some problem, that Kubernetes will respect the things that you are doing. So if you're saying that you need this amount of replicas to be serving, if, I don't know, maybe you have an SRE or a platform engineer that's going to migrate your Kubernetes or doing some kind of upgrade, the Kube API server will guarantee that it will not disruption based on your specifications. And at some point it will be done, and it's done, right? So now, so as you guys saw in the previous one, it was almost immediate because Kubernetes was like, okay, drain this node out, I'll kill everything, done. Here, it just waited for a little while until everything was scheduled on another node. So this is something that a lot of companies already use, but it's something I feel that it's a little bit underappreciated. A lot of companies not use it, but it's something that can make our lives a lot easier, specifically when you have multiple teams managing different parts of the cluster. I'm an application developer. I need to guarantee some resilience for my workload, but I also need to ensure that my colleagues from platform engineering SREs are able to do that work, and there's some API in the middle that will guarantee the constraints that both have to deal with. And last but not least, I want to talk a little bit about priority classes. Does anyone here have implemented on their infrastructure services graceful degradation? This can be done in multiple ways. So the idea, I don't know if everyone's familiar with the concept of graceful degradation for services, but it's this idea that I have an entire system, and there are parts of the system that are more important than others. And I want to gracefully degrade my system while still providing a function to my services. Let's imagine an e-commerce website. At the end of the day, what I want is for people to find my product and buy it. If I need to disable search temporarily just to make sure that users can still buy, it's probably better than having everything down. So the idea for graceful degradation is, what are the things that I can degrade so that I can maintain the core functionality of my services up? There are several projects under the CNCF that can allow us to do that. Kubernetes, out of the box, has this concept of a priority class. And the priority class is nothing more. I give a score to my deployments. And if Kubernetes needs to make a decision on what to kill, it will use that. Right? If you don't tell it anything, it will use the Linux kernel default definitions. Usually it will be around memory consumption and whatnot. It will kill the stuff that it's using more resources. When you set a priority class, you're basically telling, here are my bunch of applications. Here's a priority list. If you need to do anything, if you need to kill something, just use this list and then kill the stuff that are less important. It's a way for you to tell Kubernetes what is your priority in terms of what's more important. You probably all have like services that are P1s, right? So this is our critical to my infrastructure, and others that, okay, if this goes down for 30 minutes, it's not a big deal. We can deal with it. Of course, ideally you want everything up, but if you get into a situation where you really have to make a decision, Kubernetes gives you some stuff out of the box. So let's see how that works. So again, just our usual deployment, right? Just creating, filler deployment. Here's just an example of a filler. So what I'm going to do in this example, I'm just going to fill the cluster. So I'm going to schedule as much as possible, as much as I can, just adjust for the size of your cluster. And then I'm going to try to deploy something when there's no space, right? So, and let's see what happens. So let's deploy the filler first. I don't even know how many I have in the filler. Let's see. Yeah, I think I have 16. Let's see. So Kubernetes is creating, I think this is an Nginx resource. So it's creating a bunch of resources. And as you guys can see here, it's already, some of them are already pending. So this cluster is super, super small, so I'm probably already scheduling a lot more stuff, right, than I probably should. So the idea here is that I'll have some pending stuff, but again, I could manage this to smaller sizes to make sure that all of them were running, right? What happens if I try to deploy this pod? So you guys are already seeing that I cannot deploy this pod. So what will happen is that I will deploy my high priority pod, right? I cheated because I had done this already. But we'll see an example in a few seconds. If I do the filler here. Okay, so now we have it. So I already had priority classes defined. That's why I was able to do this. Here, now this is a problem, right? So I'm trying to schedule something. I know that that's higher priority, and I can't because Kubernetes has no way of deciding. So you have this stuff running. You ask for more stuff. I can't do it. It will skip there. So I can twist this. So I can create something that you guys already know. That is a priority class. So in these examples, I'm using 2 priority classes. I'm creating a priority class high priority, and it has a name, and it's basically it has a value, right? So I give it the higher the value, the more priority the deployment has, and then I have a low priority. And what I'm going to do is I'm going to say that Nginx is low priority, and my application is high priority. So as an example here, I'm setting the deployment has high priority. Okay, let's clean things up just to make sure. Okay. So now we get back to square one. It's launching my services, but now it has a priority class, so there's nothing else there, so it's just booting stuff up, right? It's creating containers. At some point, it will not be able to do more. But then I'll apply my high priority deployment. And again, as you guys can see, there are service containers that are pending, but my high priority services are already running. This runs through the life cycle. This is just an example for demo purposes, that even if I launch something that there's already stuff running on the cluster, Kubernetes will unschedule those things and put my stuff on high priority. But it will happen the same thing if I start deleting stuff. Kubernetes will prioritize the higher priority workloads. So actually, let's try this. I haven't tried this, but if I start draining and I'm unlucky and I hit a node, so now there are more filler pods pending, but the high priority ones are still working, because Kubernetes will say, okay, even if I need to reshuffle things, I will prioritize these ones first. Yeah. It will make those decisions for you. If you don't tell it anything, it will just maintain the ones that are running. Those, because that's I think that's a default, right? If it's already running, it's not going to kill it. It's running, and bad luck. You, like, first come, first serve. If you give it these resources, okay, now I have more stuff to put in my algorithm to make that decision. And basically what I'm telling here is, okay, this is a lot more priority than this filler thing that you have here. So if you need to kill stuff, these are the ones that you. So we use a lot of this for, besides what we were talking about, like from between P1 and P5 services, right? And it's okay, if you need to do whatever, if you're doing an upgrade and there's a problem, if you don't have spare capacity, prioritize these workloads. These are the most critical ones. These are the ones that will provide the customer service that I want. If you need to do something else, just delete those. Of course, we have monitoring on top of this to understand, okay, we don't want this to be running ad eternum, but if I need to deprioritize some things, these are the ones that I'm telling you out of the box. If not, Kubernetes have no idea. So these Kubernetes algorithms over the years have evolved a lot to accept a lot of these arguments, and that you can customize and say, make your decision on top of this. Any question? Okay, so I had this presentation for 2 hours, and then I was told that it was 3, so we're almost at the 2-hour mark. But just to recap, and I know that a few people just joined a little bit later. We touched on the topics on the left, right? So we kind of overviewed what they are, those concepts. Eventually, this workshop will touch on a lot more of this. We'll probably do in segments, because some of these concepts start to get more and more complex, and other stuff is not native to Kubernetes. You need to install tooling, etc., etc. But just to go, I try to divide this. So I usually, when I do these things, I try to think about what are the stuff that I can do a runtime. So the application is already running. How do I deal with failure? And then separate at deployment time, because deployment is a disruptive thing that we do to our services. We're changing stuff, and how do we deal if something goes bad? So under deployment, we just saw the recreate and rolling update. That's native to Kubernetes, and that's the only thing that it knows how to do. Right? It doesn't know how to do anything else. There's a lot more deployment patterns that we can use. So blue-green deployment, okay, you have blue, you have green, you do an update, you do a switch, right? If something goes bad, you can easily go back and say, okay, we go back. The disadvantage of, or the biggest difficulty is blue-green, is that you usually need 2 replicas of the same size of your application. If it's a big application, if it's a big infrastructure, you will have a lot of infrastructure to do this. But the switchback is super easy, because you just point traffic to the new version. If there's any problem, I just switch it back. But you have the 2 versions running at the same time. This is not native to Kubernetes. There are ways for you to do it if you want to do your own tooling, or you use something on top, because there's nothing, and basically that's what tools like Argo do. It's basically they create deployments with different labels, and that's what they do, right? So they go to the service, and now you're pointing to this label. If there's a problem, they point it back. So it's not native to Kubernetes, but it's not, so you don't need an extra tooling on top of Kubernetes. You just need to play with the things that exist, but it can be done. Canary deployments is this idea that I'm going to, so does anyone implement canary deployments? Anyone knows what I do? Okay. So the idea for canary deployments is actually coming from miners. So miners, I don't know if they still do this, but they used to take a canary into the coal mine, specifically for coal mine, because canaries are more susceptible to gases than humans, and if the canary fainted, they knew that there was a problem. The canaries didn't die because they were just like doozy with the gases, but the miners knew that they need to flee the mine because there was some gas that they couldn't smell, that maybe there's an explosion coming or they were all falling. The idea for canary deployments is the exact same thing, right? You are going to expose a small subset of users to your new version of the application. You are going to monitor it. Hopefully, you're going to do this in an automated manner. If not, it is a pain in the ass. And then you roll out to more and more and more and more and more until everyone is using your new version. So for this, you can do this without a service mesh or a service mesh-like thing, but it gets trickier, and you don't have a lot of control over, or you don't have precise control on the amount of traffic. So some stuff like Istio or Linkerd or whatever gives you more network control, but you don't have to do this. So for example, if I want to expose 30% of my users to my application, I can just launch 10 replicas, 7 will have the old version, 3 will have the new version, and users will have their. I won't have as much control because Kubernetes, if I only use services as a native, it will run, but at least 30% of my users will use the same version. Dark launches is the idea that I will launch my application, but not everyone will have access to it, right? So only selected part. You can do this in multiple ways. For example, you can give users a specific header, and then on your routing scheme, you say, okay, if users have this header, the requests have this header, just route them to this application. You can do that with feature flags, saying you can enable feature flags for specific users using specific devices or specific accounts to do this. But it's this idea that you are going to launch things hidden underneath the covers, and then when you're okay with going GA, you can put everyone out. At a previous company that I worked, once we implemented this, so I was on the platform team, once we implemented this, most of our lower level environments for testing, developers started using it less and less because they had canary deployments, so they have confidence of going to prod, that if there's a problem, they could switch closer back, and then they could use Dark to actually put stuff that everyone is using. So we had a lot more stuff going to prod faster because they were more confident if there was a problem, they could detect it faster, then they could roll it back, right? But it's just a concept. Init containers is a special container that you can run when you start your applications. It will run before all of your containers run, and you can use it for whatever. Maybe you need some special setup for your application, and it will do that. Now you can, I think it was in 133, or is it 134, where you can say that the init container can continue running for the rest of the life cycle of the pod. It will start first. You can then trigger the other ones, but it can run it. So for example, one use case for that is maybe you have an init container that manages getting some secret and setting something on a file or something like that. I don't know, something like that. And then at some point, so you did it in the beginning, and then the application runs. And then that credential gets expired. If you have that init container running, now that's one of the use cases. That init container can pick up that work again and say, okay, so the application can't deal with this, so I'll get the secret, I'll put it then, and I'll restart the application. Whatever you need to do. But this is this idea that you can have a container that will start before the others, and only if it succeeds, all of the others will start. So a lot of people use this also for migrations. So you run your database migrations on your init container, and once it's done and it's successful, okay, now I can start the applications because the new version of the database is already deployed. Again, database migrations, how do I deal with database migrations when I'm doing big upgrades? And admission controllers, which is something that Kubernetes provides out of the box, but is this idea that we briefly touched on it when we talked about CRDs and operators and whatnot, but I can have admission controllers that Kubernetes will route information there, and depending on the response that it gets back, it will do stuff. The two most used ones are the validating mutation webhook, where basically Kubernetes will receive, okay, create a deployment. It will send to an endpoint that registered on that validating webhook, and if it receives the 200 back, say, okay, I can do what I'm supposed to do. Stuff like, for example, Kyverno to apply policies is something that uses the validating the admission webhook, because you will send an deployment, Kubernetes will send that deployment to Kyverno, and Kyverno will validate if that deployment is actually compliant with what it's. If it's not, it will tell Kubernetes you cannot deploy this thing, right? The mutation webhook is similar, but it will Kubernetes will inspect the response because the mutating webhook will actually change. If I send a deployment, so for example, you can do that with Kyverno as well, or you, for example, you want to ensure that every deployment that you do has requests, for example. If you create a deployment that has nothing, right, you can have an operator that says, okay, here's a deployment, you created it without a request. It will respond back with the same deployment with the request is added. So that's why it's called the mutating webhook. It will get your resource, it will deploy your resource back, but with some additions. And that's basically admission control. And then you can do whatever you want with it because you will need to give it an endpoint. Kubernetes will forward the request there, and it will expect a response back. About runtime, so the most common ones, rate limiting. So how do you make sure that your applications are not receiving more traffic than they should? Bulkheads is similar or related with graceful degradation. So bulkheads come from shipping industry. So if you could peel a boat, you would see that it's built in divisions, and you've probably all seen films where there's a flood in one part of the boat and they just seal it. That's a bulkhead. So basically is how do we contain problems in our systems. If there's a problem with whatever, with search on my website that it's trying to affect other stuff, I'll just seal it there. There's multiple ways that we can do this using Kubernetes, like stuff like network policies to limit the amount of requests. So if I have one pod that is been attacked by some hacker, if I have network policies, it means that the hacker will not be able to just infiltrate and do whatever it wants, but there are projects that will help us to isolate our services into compartments. Circuit breaking, again, another analogy that doesn't come from industry, but comes from electronics. So you probably all had a surge in your house, and then suddenly you heard boom. You heard a boom, and your switches are down, right? So if you have a spike in electricity, your system will open the circuit, and it will not allow to burn all your TVs and washing machines. The idea here is the same, right? You have projects that will allow you to monitor certain replicas of your application, and if based on your criteria, that replica is flooded for some reason, and it could be number of requests, it's using too much CPU, the circuit will break, and the system will say, okay, this thing here needs to breathe for a little bit, and once it's back online, I'll start shifting traffic again. So projects like Istio or Linkerd have this out of the box. You specifications say, okay, I know that each replica of my application can handle 100 requests at the same time. If I start sending it more, it will say, no, you're capped at 100, and once it goes below that, I don't send more, or CPU. If it's using 90% of CPU for the last 5 minutes, this thing is too flooded, so I'll just give it a go. Pod topology spread constraints and affinity and anti-affinity is a way that we have to just say to our applications, don't run everything on the same nodes, right? So if you don't tail anything to Kubernetes, the default mechanism for scheduling is the nodes that are the least occupied. So if you just if your Carpenter scaler just launched a new node, it's more than likely that whatever you launch next is going to that node. If you launch 10 pods of a new service, it's very likely that most of them will land there. So you launch 10 pods and like 9 are sitting there. When you use anti-affinity or affinity and pod topology spread constraints, what you are telling Kubernetes is, how do you want to spread things on your cluster, just to make sure that I don't have everything running on the same node and I have some of my nodes, some of those pods spread out. Taints and tolerations. This is basically the idea that and this is all based on labels. I put labels on my nodes, and I basically tell Kubernetes, this can run here and can't run here. So the taints is basically labels that I add to my nodes, whatever. And what I can say is, you can run here or not, right? It's those things where, for example, maybe you need GPUs, right? So you can taint a node saying this has GPUs, and then you can say, okay, this workload can run you can use the node selector. There are several ways to do this. You can use the node selector directly and say, okay, you can run here, or you can tolerate some taint, right? And this idea that you taint stuff, and only stuff that has that toleration will be able to run on those nodes. Rest of the stuff, like sidecar pattern, it's an idea that I can run multiple pods, multiple containers on the same pod, and usually they have different responsibilities, right?
Operators, we start getting into more complex stuff here. So it's the idea that you will add your own logic to your Kubernetes containers. You will start creating the Ricardo resources, and there will be one operator that will manage the Ricardo, whatever that is. But then that will involve a lot of stuff. So just as an example, I have a friend that works at a database company, and they manage their whole thing. Everything is operators. So they launch Kubernetes, and Terraform, etc. And then everything that I have is an operator. But they create their own databases, so they sell database as a product, and everything is an operator. Their whole system is based on managing operators. And of course, they have built-in logic because it's a database. They need it to operate a certain way and they need to do it that way. So, and it's often used for that. Like I was telling before, operators are often used for stateful applications because stateful applications will have different ways that they need to function, and operators will add that extra logic. Network policies, what is our talking about? Like how do you control the traffic that comes in and comes out? So you can, we didn't touch here, but Kubernetes has this concept of namespaces, and it's just a logical grouping of resources. It's not physical, but at the namespace level, I can apply a lot of stuff. And one of them is network policies. So I can tell at the at the namespace level what traffic can come in and what traffic can come out. So I can block stuff or only allow stuff to where I want it to go. The Gateway API is kind of a new thing, and it's Kubernetes response to more of a service mesh. So if you deployed service meshes on your clusters, you know that Istio will have its resources, Linkerd will have its resources, Cilium will have its resources, one will have virtual services, Linkerd has another thing. The Gateway API is Kubernetes going the route of creating abstract resources that then each of the service meshes or each of the provider will implement that. But they will all implement, so the object is the same, but the implementation will be different. Each provider can do that. It's getting a lot of traffic, and you will get directly from the Kubernetes API with native objects, not native implementations, but with native objects, service mesh kind of stuff. You can implement canary deployment, circuit breaking, rate limiting, etc. Topology-aware routing is where you turn your services more resilient by making sure that your routing is more efficient. So you probably want two services that are communicating that have replicas sitting next to each other to be communicating. If you go through the service, it will do round robin, right? So if you have a big cluster, it could have like thousands of replicas, and you have no way, if you don't do topology-aware routing, where the request will end, and maybe you have two pods that are living on the same node, and it will be a lot faster. So this is just a silly example, but with topology-aware routing, you make your routing inside a cluster topology-aware, and it will be more efficient in the way that it will manage those requests. And then there are some foundational stuff that we didn't see. So ingress is the way that you usually ingress and Gateway API. So most likely ingress will die over time in favor of the Gateway API, but it's the most common way to receive traffic from outside the cluster. You create an ingress resource, and then you have a controller, again, that's looking. It could be Nginx, it could be AJ Proxy, whatever you want, that it's looking at that ingress and say, okay, if Ricardo.com, I receive this request, I know that I need to send it to that thing. Daemon sets it was the first attempt of having some I was talking about stateful sets. I'll go to daemon sets first. Daemon sets is a construct that will, if you apply that, it will ensure that it runs one replica of your pod in each node, right? So let's say that you have a very useful for logging. So when you want a logging daemon, you want a logging daemon running on each of your nodes because applications will log to std out. So you want something there monitoring it, shipping it somewhere. So you basically deploy a daemon set. And Kubernetes will ensure that one replica of, for example, Fluentd will run on each pod and it will do its thing. Stateful set was the first application of having some state associated with a pod. So when you deploy, if you notice when we launch a pod, it will have like resilient workload, blah, blah, 1, 2, 3, F, blah, 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 whatever it may be. Stateful sets has two interesting things. Will be that the pods will always have the same name, so you can count on that state, and they will have a rollout, roll-in that will always be the same. So
stateful sets will always add 0 up to the value that you want. So you will have resilient workload app 0, resilient workload app 1, resilient workload 3. So if you are counting on going directly to a pod, you can count on that state, because if you have 5 replicas, you will have pods 0 to 4. You know that they will be there. And you know that when you do an update, it will go from 0 to 5, and you want to do update, it will do the backwards. So you can count on that. So when you deploy a deployment, you have no idea, right? So Kubernetes will start killing shit. When you have a stateful set, it will follow that pattern. It will go 0 to 4. You do an upgrade, it will go 4, 3, 2, 1, 0, and then bring them back up. So it's this idea. Over time, I will create a lot more challenges for this, but this will require a lot more involvement, engagement, so some stuff there. So operators by themselves is like 2 days workshop, right? Because that actually involves writing code and making sure. Of course, we can do this in a few hours if we can something with pre-baked in. But there's a lot of stuff from creating the CRDs, using admission controllers, mutating webhooks, just having something that we want to manage and making it interesting. But it requires a lot of work. And that's it, guys. Thank you very much. Hope you enjoyed. If you have any questions, just feel free to shoot.